Hello students, here we discussing the remaining example in unit number 3 vector differentiation. So let's move on. Our next example is prove that, here PT means prove that first result is divergence of cross product R bar cross A bar is equal to 0. That means to find divergence of R bar cross A bar and to prove is equal to 0. Our next result is to prove curl of R bar cross A bar is equal to minus 2A bar, where A bar is any constant vector. So first of all here we prove first result and next we will discuss the second one. So write down, first we prove divergence of R bar cross A bar is equal to 0. So first of all here we define our vector R bar and A bar. First of all here we find the cross product of R bar cross A bar, and after that we find its divergence. So first of all here we write as let, as we know our vector R bar is defined as the xi cap plus yj cap plus z k cap. Now we define the vector A as a1i cap plus a2j cap plus a3k cap. Now see, our vector A bar is any constant vector and defined in this form a1i cap plus a2j cap plus a3k cap, where a1, a2, a3 are any constant Now first of all we obtain R bar cross A bar. That means here we obtain cross product of vector R bar and A bar. As you know how to define, ijk coordinate of vector R bar, and coordinate of vector R bar is x, y and z. X, y, z. Here we write the coordinate of vector A bar, and coordinate of vector A bar is a1, a2, a3. a1, a2, a3. Now we simplify this. So if we simplify this, then we get ya3 minus a2z. That means a3y minus a2z into I cap minus a3x minus a1z. a3x minus a1z into j cap plus a2x minus a1y. a2x minus a1y into k cap. So this is the cross product R bar cross A bar. Now we find its divergence. So now to prove divergence of R bar cross A bar is equal to 0, that means here we find divergence of cross product R bar cross A bar. મિત્રો આપણને જે cross product મળ્યો છે R bar cross A bar એનો આપણે divergence find કરીશું. So this term a1 a3y minus a2z is the f1. So here we write as our f1 term is a3y minus a2z. Our f2 term is, here is the minus multiplying x, so our term becomes the a1z minus a3x. Minus ને આપણે inside multiply કરાવી દઈએ તો આપણી term થઈ જશે a1z minus a3x. And our f3 term is a2x minus a1y. Now we find divergence. So divergence of R bar cross A bar as our formula del f1 upon del x plus del f2 upon del y plus del f3 upon del z. So here we are doing partial derivative of f1 with respect to x. So here we write as the del upon del x. Our f1 term is the a3y minus a2z plus del upon del y. Our f2 term is this a1z minus a3x plus del upon del z. Our f3 term is this a2x minus a1y. Now to doing partial derivative of a3y minus a2z with respect to x. તો મિત્રો આખી ટર્મ કેવી કાઉન્ટ થશે? કોન્સ્ટન્ટ કાઉન્ટ થશે, કારણ કે આ જે ટર્મ છે એમાં x વાળી ટર્મ છે નહીં. સો ધેટ મીન્સ પાર્શિયલ ડેરિવેટિવ ઓફ a3y minus a2z with respect to x is the 0. Similarly, a1z minus a3x, these terms not contain the terms of the y. That means this terms is the constant when doing the partial derivative with respect to y. So again get the 0. And last term a2x minus a1y, એમાં પણ z વાળી ટર્મ આવેલી છે નહીં, અને આપણે પાર્શિયલ ડેરિવેટિવ વિથ રિસ્પેક્ટ ટુ z કરી છે. ધેટ મીન્સ આ આખી ટર્મ કેવી કાઉન્ટ થશે? constant. So again its derivative with respect to z is the 0. So final answer is the 0 is nothing but the RHS. So this is the proof of our first result. મિત્રો આપણે પ્રૂફ એ કરવાનું હતું કે ડાયવર્જન્સ ઓફ આર બાર ક્રોસ એ બાર ઇઝ ઇક્વલ ટુ 0. સો આપણે જે ડાયવર્જન્સ મેળવવાનો છે કેનો મેળવવાનો છે આર બાર ક્રોસ એ બારનો. સો ફર્સ્ટ ઓફ ઓલ હિયર વી ઓબ્ટેન આર બાર ક્રોસ એ બાર, that means the cross product of vector r and vector a. So first of all here we define the vector r bar as we know xi cap plus yj cap plus zk cap, and here we define any constant vector say a1i cap plus a2j cap plus a3k cap, and first of all here we find its cross product. Next we find its divergence, and its divergence is the 0. That means divergence of r bar cross a bar is equal to 0. So this is the proof of the first one. Now we see the proof of the second one. So in second one, to prove curl of r bar cross a bar is equal to minus 2a bar. મિત્રો આપણે કર્લ કેનો ફાઇન્ડ કરવાનો છે r bar cross a bar નો, and we already find r bar cross a bar. Here we already define the r bar cross a bar. So this is our f1 term, f2 term and f3 term. So here we find its curl. So let us see proof of the second one. Curl of r bar cross a bar is equal to minus 2a bar. મિત્રો આપણે જે આગળ ડિફાઇન કરેલ છે એજ ઇટ ઇઝ રહેશે. Now we find the curl of r bar cross a bar. So here we apply the our formula. Curl of r bar cross a bar is equal to, our formula is the ijk del upon del x del upon del y del upon del z. Here we write the f1, f2, f3. Our f1 term is the a3y minus a2z. Our f2 term is a1z minus a3x. f3 term is the a2x minus a1y. Now we just simplify this. So del upon del y into a2x minus a1y minus del upon del z into a1z minus a3x into I cap minus del upon del x into a2x minus a1y minus del upon del z into a3y minus a2z into j cap plus del by del x a1z minus a3x minus del upon del y into a3y minus a2z into j cap. Now we just simplify, we get the answer. Here we are doing partial derivative of a2x minus a1y with respect to y. That means અહીંથી આપણે કોને કીધું થશે આ જે ટર્મ છે a2x minus a1y એનું with respect to y કરી છે તો a2x નું થઈ જશે 0 minus a1y નું થશે minus a1 minus જે સેકન્ડ ટર્મ છે a1z minus a3x એનું with respect to z કરી છે તો a1z નું થશે a1. So a1 minus a3x નું with respect to z થઈ જશે 0 into I cap. Now minus a2x minus ay with respect to x કરીશું તો અહીંથી એડજસ્ટ થશે a2 minus a1y નું થઈ જશે 0 minus a3y minus a2z with respect to z કરીશું તો a3y નું થઈ જશે 0 minus a2z નું થશે a2 into j cap plus a1z minus a3x એનું with respect to x કરીશું તો a1z નું થશે 0 a1 minus a3x નું થશે a3 minus આ ટર્મ છે આપણી a3y minus a2z એનું with respect to y કરીશું તો a3y માંથી આપણે મળશે a3 a2z નું થઈ જશે 0. Okay. Now we just simplify, we get the answer here. Now see minus a1 minus a1, so minus 2a1 I cap, minus a2, here minus minus plus a2, पर जे आगे माइनस ये पण लागू पड़े એટલે થઈ જશે માઇનસ a1. નાવ સી માઇનસ માઇનસ પ્લસ a2 અને આ આગળ જે માઇનસ હતા એ આવશે એટલે થઈ જશે માઇનસ 2a2, સો માઇનસ 2a2 j cap, or you can also say minus minus plus a2 plus a2 2a2 અને આગળ જે માઇનસ હતા એટલે થઈ જશે માઇનસ 2a2 into j cap. In last term minus a3 and minus a3, that means minus 2a3 j cap. Now take minus 2 outside, minus 2 take outside, so remain the a1 I cap plus a2 j cap plus a3 k cap, and this is nothing but our vector a bar, so here we write as the minus 2a bar is nothing but RHS side. So this is the simple proof of our second result. I hope you understood how to prove both the result. Now we see the second one. Now in second example, you have given prove that divergence of capital F of R dot product with the vector R bar is equal to 3 into capital F of R plus R into F dash R. Here capital F of R is any function of R. જે capital F of R આપેલું છે તમને એ કોઈ R નું function હશે. And to prove is equal to 3 capital F of R plus R into F dash R. F dash R denote the first derivative of our function F of R. Here we start our proof with the LHS side and we obtain the RHS side. તો આપણે જે ડાયવર્જન્સ ફાઇન્ડ કરવાનો છે એ કેપિટલ એફ ઓફ આર ડોટ પ્રોડક્ટ વિથ ધી આર બાર સાથે ફાઇન્ડ કરવાનો છે. સો ફર્સ્ટ ઓફ ઓલ હિયર વી ઓબ્ટેન કેપિટલ એફ ઓફ આર ડોટ પ્રોડક્ટ વિથ ધી આર બાર. લેટ્સ સી સોલ્યુશન. So first of all here we know that vector r bar is xi cap plus yj cap plus z k cap. Now we obtain capital F of r dot product with the r bar. So here we multiply our function f of r bar with the our vector r bar. So f of capital R into xi cap plus capital F of r into y j cap plus capital F of R into J into K cap. Now we find its divergence. Now our F1 is these terms. Here we write as our F1 is capital F of R into X. Our F2 is capital F of R into Y. And our F3 is capital F of R into Z. Now we find its divergence. So here we prove. Start with the LHS side. So LHS is equal to divergence of f of r dot product with the r bar is equal to, formula of the divergence is del f1 upon del x plus del f2 upon del y plus del f3 upon del z. So here we are doing partial derivative of f1 with respect to x. That means here we write as the del upon del x. Our f1 term is the capital F of R into X plus del upon del Y capital F of R into Y plus del upon del Z capital F of R into Z. Now see, f of r is a function of r and r is a function of x, y, z. So f of r is not a constant function. So in short, f of r is also function of x, y, z. So here we apply our multiplication rule, and here we doing partial derivative of f of r with into x with respect to x. So see here, f of r as it is, x નું with respect to x કરીશી થશે 1 plus x as it is કેપિટલ એફ ઓફ આરનું વિથ રિસ્પેક્ટ ટુ એક્સ કરીએ તો કેપિટલ એફ ઓફ આરનું થશે લખાશે એફ ડેશ આર. હજી મિત્રો અહીંયા પૂરું નથી થઈ ગયું. બાજુમાં શું આવશે? વિથ રિસ્પેક્ટ ટુ એક્સ કરીએ છીએ, ધેટ મીન્સ લખાશે ડેલ આર બાય ડેલ એક્સ. એફ ઓફ આર એઝ ઇટ ઇઝ એક્સનું 1 પ્લસ એક્સ એઝ ઇટ ઇઝ એફ ઓફ આરનું વિથ રિસ્પેક્ટ ટુ એક્સ થશે એફ ડેશ આર અને બાજુમાં થશે આરનું વિથ રિસ્પેક્ટ ટુ એક્સ, ધેટ મીન્સ ડેલ આર બાય ડેલ એક્સ. સિમિલરલી હિયર વી ડુઈંગ રિમેનિંગ ટુ ટર્મ્સ પ્લસ f of r as it is y નું with respect to y થઈ જશે 1 પ્લસ y as it is f of r નું થશે f dash r અને બાજુમાં થશે del r by del y પ્લસ here f of r as it is z નું with respect to z થઈ જશે 1 પ્લસ z એજ ઇટ ઇઝ f ઓફ r નું થશે f ડેશ r અને બાજુમાં થશે del r by del z. As we know, value of del r by del x is the x by r, value of del r by del y is the y by r, and value of del r by del z is the z by r. So here we just substitute the values. So is equal to, now see, f of r, f of r, f of r. So here we write the 3 times capital F of r. Now plus, here we substitute the remaining value, del r by del x is the x by r. So here we write as the x into capital F dash r, value of del r by del x is the x by r, x by r, plus similarly here we write as the y into f dash r, value of del r by del y is the y by r, plus z into f dash r and value of del r by del z is the z by r. Now just simplify. 3 into capital F of r as it is. Now take f dash r common in all these terms. મિત્રો દરેક ટર્મ્સમાંથી f dash r કોમન નીકળી જશે. f dash r, f dash r, f dash r. અને દરેક ટર્મ્સમાંથી હજી કોમન નીકળશે 1 upon r, 1 upon r, 1 upon r, 1 upon r. So here we take also 1 upon r outside. મિત્રો ટર્મ્સમાં રહેશે x into x, x square, plus y into y, y square, plus z into z, z square. મિત્રો જે આ બાકીની ટર્મ છે એમાંથી આપણે f dash r upon r કોમન લીધા છે તો વધશે x square plus y square plus z square. Now simplify this. Now we write as the 3f of r as it is plus f dash r upon r, value of x square plus y square plus z square is r square. Why? Because we know r is equal to under root x square plus y square plus z square, doing this square both the side. So r square is equal to x square plus y square plus z square. So here we substitute the value of x square plus y square plus z square is nothing but the r square. So x square plus y square plus z square is r square. So final remain here 3 capital F of r plus f dash r, here 1 r is cut into r. So here we write as final 3 into capital F of r plus r into f dash r, and this is nothing but our RHS side. So this is the proof of our second example. Let us recall one more times. Now to prove divergence of capital F of r dot product with the r bar is equal to 3 into capital F of r plus r into capital F dash r. So first of all here we define capital F of r dot product with the r bar. આ જે capital F of r છે એ r નું ફંક્શન છે. So here we define as capital F of r is the function of r and r is the function of x, y and z. So here as we know vector r bar is xi cap plus yj cap plus zk cap. Now we multiply vector r bar with the function f of r. So here we write as the f of r xi cap plus f of r yj cap plus f of r zk cap. So our f1 is capital F of r x, our f2 is f of r into y, and our f3 is f of r into z. Now we find its divergence. That means here we start our proof with the LHS side. So now to find divergence of f of r dot product with the r bar. So our formula is the del f1 upon del x plus del f2 upon del y plus del f3 upon del z. Here we are doing partial derivative of f1 with respect to x, f2 with respect to y, and f3 with respect to z. So as we know f of r is not a constant function. F of r is the function of r and r is the function of x, y, z. So here we apply the multiplication rule. F of r as it is x નું થઈ જશે 1 with respect to x plus x as it is f of r નું થશે f dash r અને r આપણું જે x, y, z નું ફંક્શન છે તો બાજુમાં પાછળ થશે del r by del x. Similarly here we doing partial derivative with respect to y and with respect to z, remaining two terms. Now see f of r plus f of r plus f of r. So here we write as the 3 times f of r. હવે જે બાકીની ટર્મ છે એમાં આપણે વેલ્યુ ઓલરેડી ફાઇન્ડ કરી ચૂક્યા છીએ. del r by del x is x by r, del r by del y is y by r, and del r by del z is the z by r. So here we just substitute the value. Now we take f dash r upon 1 upon r take outside in these 3 terms. So here we take f dash r upon r outside. So remain here x square plus y square plus z square. As we know, x square plus y square plus z square is nothing but the r square. So 1 r is the cut. Remaining is 3 f of r plus r into f dash r, and this is nothing but our RHS side. So this is the proof of our second example. Now we see the next one. Now our second result is to prove that gradient of f of r is equal to f dash r dot product with the vector r bar upon r. So proof is very easy. Here we start our proof with the LHS side and we obtain the RHS side. આપણે જે ફંક્શન f of r આપેલ છે એનો ગ્રેડિયન્ટ ફાઇન્ડ કરવાનો છે. So first of all, here we understood f of r is the function of r, and as we know r is the function of x, y, z. As you already learnt in semester number 2 about the partial derivative, મિત્રો જે આપણું ફંક્શન છે del upon del x f of r, ફંક્શન f of r નું પાર્શિયલ ડેરિવેટિવ વિથ રિસ્પેક્ટ ટુ x કરીએ તો એને કઈ રીતે ડિફાઇન થશે? ફર્સ્ટ ઓફ ઓલ ડુઈંગ ધી ડેરિવેટિવ ઓફ ધીસ ફંક્શન f of r વિથ રિસ્પેક્ટ ટુ x, ધેટ મીન્સ લખાશે f dash r. So this is the f dash r. હવે r જે છે x y z નું ફંક્શન છે તો પાર્શિયલ ડેરિવેટિવ નિયમ પ્રમાણે થશે del r by del x. હિયર del r by del y and del r by del z. તો મિત્રો જ્યારે આપણે ફંક્શનનું વિથ રિસ્પેક્ટ ટુ x પાર્શિયલ ડેરિવેટિવ કરી છે ત્યારે ફોર્મ્યુલા શું બનશે? f dash r into del r by del x. When we doing partial derivative with respect to y or function f of r, તો લખાશે f dash r is equal to f dash r into del r by del y. Similarly, when we doing partial derivative with respect to z, that means del upon del z f of r can be written as the f dash r into del r by del z. As you already learned in semester number 2 about the partial derivatives rules. So here we doing partial derivative of f of r with respect to x, with respect to y and with respect to z. That means its value is f dash r del r by del x, f dash r del r by del y and f dash r del r by del z. So let's see solution of this. So here we start our proof with the LHS side. In LHS we have given gradient of function f of r. So here we just apply the formula of the gradient. As we know, formula of the gradient, જ્યારે ફંક્શન આપણું phi હોય ત્યારે આપણે ફોર્મ્યુલા કઈ રીતે ડિફાઇન કરેલી હતી? del phi by del x I cap plus del phi by del y into j cap plus del phi by del z into k cap. આપણા કેસમાં phi ની જગ્યાએ કોણ આપેલ છે? f of r. So here we apply the formula as the del upon del x f of r I cap plus del upon del y f of r j cap plus del by del z f of r into k cap. મિત્રો જે રીતે આપણે આગળ જોયું એ રીતે f of r is the function of r and r is the function of x, y, z. So here we doing partial derivative with respect to x. That means f of r નું ડેરિવેટિવ થશે f dash r અને એની બાજુમાં ડેરિવેટિવ આવશે del r by del x into del r by del x I cap. Similarly with respect to y, f dash r નું થશે f of r નું થશે f dash r અને બાજુમાં થશે del r by del y into j cap plus with respect to z f dash r into del r by del z into k cap. Now we substitute the value f dash r. What is the value of del r by del x? Is the x by r I cap plus f dash r. Value of del r by del y is the y by r into j cap plus f dash r. Value of del r by del z is the z by r into j cap. Now take f dash r upon r common in all these terms. So now we take f dash r upon r outside in all these terms. So remain here x I cap plus y j cap plus z k cap, and this is nothing but the vector r bar. So is equal to f dash r upon r dot product with the r bar, or we can also write as the f dash r dot product with the r bar upon r, and this is nothing but our RHS side. So this is the proof of our result, and it's very easy. Here we just apply the formula of the gradient, so you can easily prove these results. Now today we stop here. In next lecture we will discuss some more results. Thanks for watching this video. Thank you. Have a good all of you.